Hello Year 12 and welcome to our first video here for the next topic, vectors. Okay, so here we are with vectors, and a vector has magnitude and direction, right? How far it goes and which direction it's going. We're going to jump straight into an example here. So my vector here, we're indicating that these are vectors by having a character with this little squiggle underneath. Sometimes they're written in bold, but it doesn't. It's pretty difficult to do that in handwriting, so we're just going to stick with this notation here with a little squiggle underneath. So here's my vector A. What's equal to A? Well, here we go, A. If I was to line that up over C, it would have the same direction, right? Different magnitude, right? C is going twice as far as A. But A and D, right, I can transpose that and it's exactly the same, or as well as I could have drawn it. So the vector D is equal to the vector A. But what about the negative of A? Well, for the negative of A, it's a bit like multiplying A by -1. So I can multiply a vector, right, that has magnitude and direction, by a scalar that's just magnitude, right, and increase, or I suppose decrease, the magnitude of that vector, right? So if you like, C is like A times 2, 2A. Right? It's gone twice as far, but maintain the direction. Now, if I multiplied A by -1, right, multiplying by -1 doesn't change the magnitude of a number, just the direction. So if I have the negative of A, it's going to look more like this. And that, of course, is going to line up neatly with B. So B is the negative of A. Rightio. So we can multiply a vector by a scalar. Okay. Multiply a vector by a scalar, and that's not going to change the direction, just the magnitude. But I can add vectors together as well, and really quite easily. So here's a vector u and a vector v, and to add v to u, so u plus v, I add the tail of v to the tip of u, okay? U, v, tip to tail like that, and then I create a new vector from the beginning of u to the end of v, and that's u plus v. If I arrange those vectors the other way around, if I did v plus u, it might look a little different. To begin with, right, I would have a red line, then a green line, but I would get that same resultant vector. That's because vector addition is commutative. Right? A plus b is the same as b plus a. Vector subtraction isn't, but vector addition is commutative. The order in which I add them doesn't matter. Now, we've got another thing here. We're asked to arrange them in a parallelogram. I'm probably not going to go with the whole parallelogram, but I am going to find a plus b and a minus b. So here are my vectors a and b. So to do a plus b, I take b and I line it up so the tail of b aligns with the tip of a, and I create a resultant vector from the start of A to the end of B like that. That's A plus B, right? That purple one there. That is A plus B. Now I want to do A minus B. This is going to be like A plus negative B, if you like. So here's A. Now negative B, instead of pointing down, points up. So, from the tail of A to the tip of B, okay, there we go, and that is the vector A minus B. So far, so good. Rightio. Now I'm going to, we've got this notation here. This represents the vector from C to D. Okay, C to D. We can see that goes across 2. Now I've got these two vectors here, A and B. A goes across 1, B goes up 1. So to get from C to D, I need to use A twice. Right. Here's A in red, and you can see 2 of those takes me from C to D. Part B here, I want to go from D to C. I've got to go the opposite direction. So I'm going to need 2 negatives of A, or negative to A. Right here. From B to E, here's B, and here's E. I've got to go across 3, up 2. Right? 3 of the reds, 2 of the blues. 3A plus 2B. 3A plus 2B describes the vector BE. Now OG, right, remembering that G is the midpoint of AF, so I need to go across A units and up half of a B, A plus half B. And from E to G, here's E, here's G, back to A, so negative 2A, down 2.5, or negative 2.5B. Righto, that's it for the first video. Let's just go over some of these points. A vector has magnitude, right, how big it is, and the direction, which way it's going. Vector addition is commutative, A plus B equals B plus A. Multiplying a vector by a scalar changes the magnitude but not the direction, except sort of when we multiply by a negative, right? It reverses that direction. Rightio, that's all. Our next video is on components and column vectors. Check it out. If you've got any questions about this one, make sure you ask me. I'll see you in class. Thanks, guys.